Okay. Before we formally start, I would like to ask how many of you have already installed Python? Oh, great, I like hands, okay? For those who didn't install Python, please do so. You can try to do without Python in this Python course, but I don't think it's a good idea. And I think the way to use, tutorial will start this Wednesday. And what happened to the tutorial is, you can just go naked, okay? No, I don't mean naked. You can go without your computer, okay? But if you bring your computer and you have your Python installed, you can actually practice and do things together with the tutors, okay? So please get your Python installed. And this as a parallel session. Monday, a lot of students have problems with installing Python, actually. It's not that easy, okay? I just name a few common problems. One common problem is when you download for PC, okay? When you download this, you have that zip file. A lot of students just double click into it and then try to run the file inside, okay? What's the problem? The instruction didn't tell you to do so, okay? If you just double click it like that, it's not unzipping the file. What you need to do is go to the directory you actually download the file and right click on it. You have some extraction, whatever software you extract all, and actually we extract every file into the folder like that. Okay, so if you go back to that folder, you can see it's a folder. The original zip file is here, and then when you go in and click the install Python to install it, okay? If you don't do it, you just click into the zip file, it doesn't work. Somehow some student managed to install the Python but cannot install other packages, okay? So that is what you should do before Wednesday tutorial, okay? If you really still struggling, having problems installing Python, my highest suggestion is try to solve it, like Googling whatever. I didn't mean we don't want to help you. Actually, it's the easiest way we just help you. Or you just give your computer to your tutor and then let him install it. It's very easy, we can do that. But I assume you are in engineering department, you want to be an engineer, okay? Or you want to be a manager, you want to solve problem, okay? So it's a good thing you learn how to solve problem by Googling it, whatever, okay? So that is my recommendation to you. But of course, the tutors are there all to help. And actually last Monday, I helped a lot of students installing a lot of, but some of the students last week has some, I call it higher level problem. They mess up their computer actually. Okay, they don't know how. Some people, there are some people just instead of uninstall something, they delete something in your computer. Okay, and so on, they mess up their computer. So last week I got a very bad time of fixing some people's computer. Okay, even some students ask me why the computer cannot get on. Okay, so I don't know how to help. But anyway, so try to solve problem because we are engineer. Okay. I hope you can get into Archipelagus. We are going to use it later. What I'll do today, I know that I planned to do the selection and looping, selection and repetition. But I think it's a good thing we tie some loose end, okay? For this course, I cannot just do it by I deliver the oral knowledge to you. It's just like downloading, okay? You click and then I download the thing to you. It's not like that. I also need to understand you, okay? So there's a few ways I understand you actually. One is in the forum, that actually I'm going to answer some question in the forum. The other is when you go and watch the video on your cosmology. I hope everybody already got cosmology, right? When you watch the cosmology, there is the video there. I know that you already know the webcast. Other than you can see my handsome face again, what I will do is I actually see how much time you actually watch it in each period, okay? So if I figure out somebody or watch that specifically 5 minutes of my video a lot of time, probably I got something wrong on that. So I will try to, let's say, explain it in further in the next lecture or something, okay? That's how we communicate. Of course, you can directly send me email asking me some of the questions, but I think the best is in forum because I don't mind answering it, but usually your problem could be other people's problem. So I need to repeat the email again, okay? So for example, the good thing about forum is people ask about this, okay? Good thing happened in the cosmology forum, okay? For example, people ask, there is a question, very confused about what is this equal sign, okay? I hope not too 長氣, okay? If everybody feel it's too easy, then you raise your hand, okay? Tell me to skip. What is the thing about equal sign? What is equal, okay? You see in this example, what happened is I have four variables, right? A, B, C, D. And you can tell me what is the value for A? 3, right? B and C are 7, and then D is 3. Just use our normal common sense. You know that A has the same value as D. Is it correct? Okay, if you think it's not correct, then I need to go back to your kindergarten, okay? So A has 3 and D has 3, those have the same value. But B and C also have the same value, right? But how about A and B? A and B don't have the same value, right? So this equal sign actually use it for comparing its two values are the same. So in Python, what you can do is you ask if A is equal D here. A, I don't like this, okay? This one. A lot of, if you are not really have programming experience, you have a lot of mental blockage. What does that mean, okay? What I try to teach people is, you can actually treat it as test Python to ask him, is it a lie or is it a truth? So now I ask you, A equal D. I tell you now, right in your face, is it lie or is it a truth? A equal D is a truth, right? So if it's a truth, then actually it will return true to you, okay? For some, I ask you again, is this one, is B equal C? I tell you now, B equal C. Is it a truth or I'm telling a lie? It's true, right? I'm telling the truth, and that's why you return true. But now I tell you, now I want to tell you A is equal B. Am I lying? I'm lying, right? Because A is actually not equal to B. But the statement say A equal to B. So what is the response? Your response is liar, okay? So it's a lying, and that's why it's a false statement. That's how this operator do, okay? They actually will take your statement. You can use the word judge, okay? Judge whether the statement is right or wrong and tell you true or false. Okay, so that is equal sign. The opposite of it is this one. This one is not equal, okay? Again, if I ask you A and D at the first line over there, right? I will tell you, you can actually try to read it in English. Is the statement A is not equal to D true or false? Is it a true thing or is it a lying thing? I tell you now, A is not equal to D. But the fact is, the fact and the truth is, A actually equal to D, right? And that's why this statement is a lie. And if it's a lie, I actually return false, right? It's the same as B not equal C. And then the last statement, now I ask you, I tell you now, A is not equal to B. Am I telling the truth or not? Now I'm telling you the truth, and that's why it returned a true value, okay? So that's how you do these operators and try to understand it, okay? And one more thing is, what is the difference between I type A equal D or A equal D, okay? Can anyone tell me? The first one, I just said in the last 5 minutes, I try to compare A and D, are they the same values? But I ask you first, after this line, will the values of A or D change? No, right? Because it's just comparing whether they are true or not. It's just checking, like your teacher checking your book or the customer in tours or Woodland checking your passport. It won't destroy your passport, okay? Or some people chop like the Malaysian, but let's don't about that. But just check. Just checking will not mess up with your data. So the first line does not change any value of D or A. But how about the second line, this one? Why is it so different? If you want to say that this one is not the mathematical equal sign. In Python or in a lot of languages, this is called assignment. Assignment means I take whatever values here. Let's say D is equal to 5, or let's say, yeah, how come this one? Okay. And what I do is these values, I will override the value in A. So the A will actually change value into what D is, will override that. Okay? So what happened is, it's a possibility that the values of A will change because it's being overwritten by D. So some of the languages actually use the assignment sign, some of the language actually use this. A, instead of equal, they use a colon equal D, okay, to distinguish the equal sign. But Python make it simpler because Python use a lot of colon, so they don't want a lot of colon again. And that's why Python just use A equal D as the assignment, okay? So that is a difference. And in English, A equal D asks only if A has the same value as D. And A equal D actually overrides the value of A by the value of D, okay? That is the difference between this equal and equal, okay? I hope it get more clear, okay? For those who already expert and know it, I hope you tahan with my 長氣 nuts, okay? So, okay? The next forum question asks, what is this percentage size, okay? I know it's kind of hard, and this kind of very elementary thing is very hard to Google. Elementary means the word is very elementary. You put the percentage size in Google. I mean, Google won't tell you what is the percentage size is, okay? You don't know. It's hard to get. It's like, I think, if Python has a keyword is exactly is, is. So you want to search for the meaning of that in Google, it's hard to find, okay? It's too general. So how to find it? This one actually has a name called modulo. Modulo, okay? And what happened is, it still don't get you anywhere. The simple thing is the remainders after division. Okay, for example, 17 divided by 2. You know that 17 is an odd number, is an odd number. So after that, you divide it by 2. 17 divided by 2 is equal to 8 in integer, right? So 8 times 2 is 16. So when 17 is being minus by 2, all the way you take out 16 and the remainder is 1. And that's why this will actually give you 1, okay? And you say, what is the use? Maybe you don't know yet, but in the future few weeks or in your future career, it's very useful because you can test whether one number is divisible by the other. For example, how do I know that if the number 912 is divisible by 3? How can I tell you that? Okay? How can I do that? You have a lot of numbers, a lot of methods, okay? But what is easily done is you ask Python is 900 over 2 percentage 3 equal 0, okay? Because if 912 divided by 3, the remainder is 0, that means it's divisible, okay? So you just ask if modular is equal to divisible, then it's divisible or not, okay? So this is one of the very common way of using the percentage, okay? The other question is the truncate, okay, the integer, okay? Integer means if I have a 23.8, if what I type is int 23.8, is that always equal to 23 or what? Okay, I said it last lecture already. What Python do is just take all the decimal point and then delete it. Okay, so if it's a 23, you become 20. If it's a 23.8, it becomes 23. It won't do any round up or round down. You know, round up or round down is more than 0.5 round up, less than 0.5 round down, right? It's not what it's doing. It's called truncation. But the other tricky question is, that means every time I use this int integer function, the numbers will get smaller. Is that so? The answer is no. Why? There's some, you can actually put in a negative number. Let's say if you have negative 2.3, what is the truncation? Negative 2.3, right? Negative 2.3. You do an integer truncation, it become negative 2, right? Because you cut all the decimal points. Is it larger or smaller? Oops, it becomes larger. Negative 2 is larger than negative 2.3, okay? So it depends on the size of the numbers, it can get larger or smaller, okay? But in general, I think without problem, all positive number will get smaller and not all negative number will get bigger, okay? So that is the integer sign. And in fact, if you want to do the normal rounding up and down, you can actually use the function round. Okay, you can see that round 2.1 become 2. Round 2.6 become 3. Okay, you can use that function. Or they have other function, let's say, bring it to the ceiling or bring it to the floor. Okay, bring it to the ceiling means no matter point something, point 1, point 2, I actually rise up. 1.1, I will bring it up to 2. 1.2, I also bring up to 2. 1.0001, I also bring up to 2. Okay, that kind of manipulation, but it's just in the library. You can look up and see how it works. Okay, okay. So there's some loose ends. So if you have problem, don't hesitate to ask in forum, or somebody may answer you. And if you have problem, maybe you also look in the forum. Maybe somebody answered it already. Okay. One thing I think is worth to mention. You see the two numbers there, right? -1 and 2 minus 1. Think about it. Is these two minus or the dashed line, are they the same? Do they mean the same thing for you? Or do they work the same thing out for you? They're different, right? What is the first one? The first one here is this negative sign is actually changing whatever afterwards. You change the sign. If it's positive, become negative. Or the other way around. If it's negative, become positive. Okay, that is how it works. Let's say I put negative 2. What is it? The first negative sign will have this magic change this positive 2 into negative 2. And then this negative 2 will actually go through this negative side, become a positive 2 at the end. Okay, so this is a negative operator. You actually can change the things on your left side or right side, sorry, right side, okay? So change your thing on your right side. But this one, you all know, right, from the kindergarten, is subtraction. You have to subtract from the left and the right. Okay? That means subtraction, you must have two partners. You must have left hand and right hand holding some numbers. You cannot have a left hand, 1 minus nothing. Okay? Maybe some new math, I don't know, but you cannot do that. So the subtraction must have a right and a left partner, and that's why this two operator has two property here. One is called unary, okay? Unary means I only need one partner. I only need one number on my right, okay? On my right, negative. For example, the positive sign, and later, actually, if you think about not, is also an operator. Okay, not true become false. So you only need one values, and you don't need the left and the right side. But the other one is called binary operator, which means you need both sides. For example, plus, multiply, or division, you need to write A multiply B. You cannot say A multiply ends. Okay, you cannot do that. So this kind of thing is called binary operators. So if you go back to the presidency, you actually see, oh, where is precedence, not presidency, sorry. Ding, 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 ding. Yeah, you see the yeah, you see this? Actually, on the table, there's some. This one is the unary operator because it's the plus, negative or minus, and you will do that first. And this one you can see up here again is the addition and subtraction, which is the two different operators, okay? And that's why the order of evaluating will be very different. Okay? And some more loose, and before we go back to today's lecture, strings, I think we already talked about some string, okay? This one, banana, we already talked about it already, right? So you can actually add two strings together, just like gluing them together, like BA plus CK become BACK, okay? And you can do multiplication, NA times 2 become nana, and then plus B become banana, okay, and so on. But one thing I didn't talk about last time is a string is a structure in Python called sequence, okay? Sequence is a very powerful thing in Python, not only the string of characters, but string of anything or list of everything. But we'll talk about that in week 5. But you can imagine if you talk about A, B, C, D, E, right, like this, it's actually a series of characters or alphabet that is in order. And in that, Python, actually other languages also let you to access any one of them in any position. Okay? So, for example, if S is equal to ABCD, you can use the square blanket to access the position 0. Okay? That's how all these computer jokes is about. Computer scientists always count 0. Your kindergarten kids, right? 1, 2, 3, that's 3 persons. Computer don't do that. Computer science 0, 1, 2, there are 2 persons. Okay? So that's how computer scientists count things. The position of the index, this one is position 0, the next one is position 1, and this one is position 2, and this one is position 3, okay? So you can see that if there are 4 characters, the position is 0, 1, 2, 3. There's no 4 there, okay? If there are n characters, let's say I give you a string of n characters long, what is the last positions in position? It should be n minus 1, okay? It won't be n. So this positioning have a technical name, it's called index, okay? So it's index 0, index 1, index is like their label, okay, which position they are. So when I access the position, 0, you give you the first number, which is A, okay? So you can understand now why position 2 is actually C. Right? Because it's 0, 1, 2. The position 0 is actually C. Okay? It's just 1 off with that. And the powerful thing about that is you can actually access not only 1 characters. You can actually access more than 1, like a substring, in which inside this square blanket, you can put more than 1 numbers. You can actually put 3, okay? Which is the start, stop step, okay? What happened is, let's say S is equal to that, I can actually do this. What does that mean? If you just put 2, it's the start and the stop. That means I want the subsection of this string starting from 0 until index 2. Okay? 0, 1, but the interesting thing is, it won't get 2. The last number is exclusive, we said it, okay? So if it's 0 to 2, it will get 0, 1, no 2, okay? So there's no 2, 0, 1. Let's say I want to start with position 1, which is the B character, right? Do I get 2? No, because it's exclusive. So this one will only give you B, okay? And so on. So this colon actually let you to get a subset or a substring of certain string easily. And how about this? Is it a syntax error? It was, but now not, because Python think it actually is a good way to get people lazy around, okay? If you don't give you numbers before the colon, Python will assume the starting position will be some numbers, and you can guess what is that number. 0, very good, you guys got intuition, okay? So, if you don't give you the position like this, it will assume that it starts from 0 to 2, which is the same as this one, okay? And that's why you also got AB, okay? And you guess what if I left out this one? Let's say I want to say S colon nothing, okay? Oh, S 0 colon nothing. What would that be? Then I assume the last one, so it's the whole string, okay? In tutorial, we'll in detail tell you what are the defaults and even tell you what is the negative, okay? So in tutorial, because I just give you an overview, and tutorial will detailedly tell you what are all this. And you can even give you the give the third number. So if you interpret the first two, 1 to 5, right? 1 to 5 means I start with position 1, which is the letter B. And all the way to 5, which is B, C, D, E. Do I include F? No, because F is the position 5, but exclusive 5, okay? So it's B, C, D, E. But this 3 means, so it's B, C, D, E, right? This 3 means after each one, I will jump 3 times, which means I will skip to the third position. So I will get B, and I will jump, 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 and the next character I will get E. So this one, actually, I will get BE. Okay? The normal one without that is every time you just 1, okay? You just jump 1 time. But if you give it a 3, that means instead of jumping 1, I jump 3 times. Okay? Until it ends or something. So you actually can get like, for example, if I will say, just now that one, right? Let's say, I actually have another example. For example, this one, if colon, it means from start to end, right? So it's the default values. But every time it jumps 2. So I start with A, and the next one will be C, and then the next one will be E. So the answer for that is ACE, okay, and so on. So it's the jumping and string slicing. And this one is not only for string slicing. Later, when you learn about list, sequences, array, they all can apply this so-called rules, okay? And the last one, I won't tell you what it is, okay? You try to think about that. What is this -1? And if you can try out on your computer or something, but if you still don't, you can go to the tutorial, we'll exactly tell you what it is, okay? So those are the string slicing. And you can actually do a lot of interesting things with strings, okay, like ASCII, arts, and so on. Okay, those are the loose end we haven't talked about last week, okay? And we actually haven't talked about the functions, okay? Functions, we talk about the functions. We define a function like that. Our functions, okay? So, but the thing is, you can write your own function, which is what we are going to do all the time. But what happens if you, let's say you want to do a function, we all talk about this, right? Last time we already talked about all this, how to write a function and so on. But how about if I want to use the function cosine, okay? Of course I can write it, which you will have some exercise doing that. But probably in this planet Earth, somebody need that function before. Somebody would have used cosine function before. And somebody would have wrote the code before already, okay? So what happened is, I can actually get it from a library, okay? Library means somebody great before me or whatever should have written some very cool and efficient code, and everybody is running already. Well, you can take the chance of doing it from the scratch for your own challenge, but if I were you doing assignment, whatever, I can actually reuse the function, right? And that's actually what computer science do. We try to minimize redundant work again and again, okay? So what happened is, in Python, it's like games. I don't know how many of you play this game. Anyone played this game before? You guys are not qualified to be gamers. No, this is an old game, okay? So what this game do is, it actually goes for mission, and mission have different ways. You can go to mission and just shoot people, okay? Or you can go to mission that you have to go stealth, okay? You cannot be discovered by people. So what you actually have to equip to the question, to the mission, can be very different, okay? For example, this mission, you bring a dog, and you try to pack as light as possible. But this one, you want to bring a partner, which is a sniper, or you can bring a jeep and bring a helicopter to support you. Or you can actually even bring a lot of different weapons and so on, okay? So that is how you play games. Why I'm mentioning this is, in Python, it's the same thing. For you want to write different program or want to write different application, you actually import or equip yourself with different functionality, okay? For example, if you want to do some math computation, you want the function cosine, or you want to use the constant pi, right? How do you do it? You can see it here. I asked the Python to print pi. Sorry, Python say I don't know what is pi. And you want to ask the Python, oh, let's print cosine 0. Python say I don't know what is cosine 0. Because the Python know nothing, okay? But what happened is you can actually import from ready-made library, which means you can write this, okay? This one is a line I want to talk about. From math, import pi and cosine. So what it goes is, it will go to the math library to import the function cosine and import the constant pi. So you can use it now. So you can actually say what is cosine pi, and Python know it now. Print cosine pi, you can actually, you know cosine pi is equal to what? Actually, I forgot what is cosine pi. Cosine pi equal to -1, okay? So it actually compute it for you. So you can use the math cosine pi, okay? This is one way of importing function, but I just want to tell you that Python, the most powerful thing is you have all different library, and then all different functions are actually ready. And if any one of you want to go for something called machine learning is just importing some library, run some code overnight, and then you are done. Okay? And that's all. You don't even need to cook something. Okay? This is one way of importing. What means is you know the math library, and you know which function you want to import. Exactly, you get it from there. But this is another way. Do you see what's the difference? This way is you just need one line. Import math. Oh, what does that do? That means in the math library, whatever function you have, tangent, cosine, pi, the natural log e, log, arctangent, whatever function, I don't care. Every function will be loaded in the memory. Okay? But then how do I use a certain function or that? You need to pronounce math.py, okay? It's different from the previous one, if you see that. The previous one, I go back to one slide. This one, when you import pi, you just need pi, okay? You don't need to say math.py. But if you use this method to import, you need to say math.py. Okay, because if you import like that, you can have a lot of library. You don't know whether this pi is for this or for the other library, okay? So this one is a bit more clumsy. And also you see the cosine, you also have to do the same thing. Math.cosine, okay? If you just do this print pi, you don't go anywhere. Okay, so that is the difference between that. Then the question is, which one do you want to use? Okay, which method? What I try to say is, you know, in this I'll talk about. Usually when you play games, right? I think nowadays games are quite ridiculous. When you go and fight a monster, you are actually bringing 700 potions on you. And maybe you are actually bringing all the equipment. You know your games, right? When you go and kill monster, you are actually bringing a few armors. Bring a few, let's say 10 swords and 20 axes with you to fight people. Okay? You do that. Well, in games, it doesn't matter. It's ridiculous, whatever. I don't care. It works, okay? But in real life, what I don't want you to do is, don't try to import too many libraries just like that. Also, okay, I import math, I import numpy, I import anything. Then I import everything. Then your memory will be loaded, okay? So the difference between this and the previous one is, this one, you go to the math library, you directly import that function or that constant you know. Okay? That means it's like I go to the NUS main library. I know exactly which book I need. And I go and get that book and just borrow that book to my home to use. Okay? But this one, what does that mean? This is when I import the whole library of math. That means I go to the NUS library, I call my servants, go and move the whole math session to my home. Okay? And then at your home, you comfortably sitting at your home and then see which book you want. Okay? So it's two different things. Of course, if you're rich enough, you have the big home to accommodate the books, whatever, is up to you. But it's not a good exercise if you have too many libraries upload and so on. So it's up to your usage, okay? Up to you to decide. And the other not so good thing about this method is you can see the the title is very clumsy. You can see that, this one. After that, you need to say, oh, math.cosine, math.pi. It's like very clumsy and very redundant, okay? One way to get around with it is try to do dot, okay? So when you import, you can actually say import math as m. Just now that one, I just say import math, right? But this one, I can say import math as m. From now, the m will be your math library. So you can just say m.cosine. Okay, it's just an abbreviation, which make your code shorter, okay? But it depends on your usage for that, okay? So it's installing packages and try not to be too loaded and so on, and yeah. All in all, you can go to the python.org, the document, or actually if you install your idols in your machine, it's all in your idle. If you press the F1 whatever, all the document is local. You don't even need to go online to search for the document, okay? All the functions are there, all the packages are there, you can actually look for it, and it's actually quite easy to look for. For example, you go to this library reference, okay? And you can actually have all this, for example, math functions, and you go into the math function, you can know whatever cosine, sine, how to use it, okay? And that is all the reference, okay? So it's tying up some loose end from last lectures, okay? So it's all the function built in, okay? So, okay. So the good thing is try out, and for those who still didn't install Python, please do so. And one thing it bugs me a bit is I still discovered that on cosmology that some people still didn't get the invitation, as in they still didn't respond. Okay, you can see that. Anyway, okay, I don't go there. Okay, in cosmology, there's still some students didn't go get the invitation and start working. Okay, so there's still 15 of them do that. So try to get it, and the first assignment is already out. Play around with it. It's actually quite simple, okay? The first assignment is supposed for you to warm up and so on, okay? So the first assignment, okay? Okay. Ready? And let's learn the next very important concept in programming, in which no matter you're programming in Python, C, Java, whatever you need this, okay? This is called repetition and selection. Overall, it's called control structure, okay? Let's say I want to write the function how to solve quadratic equation, okay? I hope I don't need to go through how to solve quadratic equation with you again, okay? So quadratic equation means you have a quadratic equation, and then what happens is you generalize the three numbers into A, B, and C, and you want to solve what is X, okay? And if you remember your high school, you have this. Okay, I don't go over how to derive it, okay? And this is how you compute. And you should give you two numbers, right? One is the plus sign, one is the minus sign. Okay? So what I just do is I implement in Python like that. See whether you can catch up, okay? So it's a function, I take in the ABC over here. And this is, what is it? It is delta, right? Delta is this guy, you see? B to power 2 minus 4 times A times C, right? And the code goes like this. B to power 2 minus 4 times A 4 times C. Okay? And the next thing is negative B plus delta divided by 2A, and that's why this is the first answer, and this is the second answer, which is 1 is plus, 1 is minus, right? And what I do is I just print out the answers. Okay? And you can actually call the function by what is the answer if A is equal to 1, B is equal to 5, and C is equal to 6. So it's x squared plus 5x plus 6 equal to 0. How to solve it? Okay? And if you solve it, you know that the answer is negative 2 and 3. Okay? So you can use that to compute your answers. So far, catch up? Anyone can tell me what will crash the program? From your secondary school, you know what is it? Yes? Say it louder, please. You know, okay. No one? What? The determinant or the delta is negative, right? The delta is negative. What happened? If I input something like that, I try to solve the equation by 118. That, okay, all the red words come out. Why? Because it tells you something called math domain errors. So when you see error, the line slide tell you what is the main problem, okay? And actually tell you which line it caused the problem is this one. Then you can guess which one caused problem. The square root, okay? Because the delta go in is a negative number and got this, okay? So if you want more details is, in this line of code, if you solve this, delta is equal to 5 squared minus 4ac, which is 25 minus 24, which is positive 1, which is okay, okay? So the math works. But if you solve this, b squared is equal to 1, and minus 8 times 4 whatsoever, which is give you a negative number, and that's why it doesn't work. Okay, the question is now what? Okay? What should we do? If the user is so naughty, try to input something like that, I just stop him. I mean, just ground him down. Okay, or what? Of course, we don't want to do that. And actually, if somebody accidentally put this like that, you will actually crash the program. What do you mean by crash your program? Imagine that you are using your app, let's say Pay Now or whatever, right? You accidentally press -1. I want to pay some people -$1. What will happen? Will it crash? It won't crash, right? We'll tell you something or it doesn't work, whatever, instead of crashing. But now the problem is crashing, which means whatever apps, whatever it is, it will stop, abort, okay? So we cannot allow things like this. That's why we need to make some decision to do the square root or not, depending on something, okay? And that's how it begins to do, for example, if delta is less than 0, actually the equation have no real solution, and we have to tell the user, I cannot compute that for you, something like that. And that is how it begins with making decision, okay? Control structure. Control structure is actually the main 3 things that you always do in programming. Basically, there are 3 types of control structures, okay? The first one is called sequencing. It's different from the sequence of the list and the string I talk about. Sequence means you actually do things in 0. Actually, it's a very simple thing in one slide. The 2 other things is called selection and repetition. Repetition, usually you heard people talk about loops, okay? And that's what we talk about. First one, sequencing, is like doing one thing by one thing. Second thing about selection is try to make choice, okay? If it's true or not, we do that. The third thing is you try to repeat something until it's end. So sequencing is very simple. It's just one slide, okay? Sequencing is a lot of people doing, let's say you want to bake a cake or make a dish. You follow the step one by one, okay? And you finish it, you're done. And in fact, you know that our program so far are all the same like that, right? You actually have all those lines and you just follow line 1, line 2, and so on. That's sequencing. Selection. Selection means, remember playing goals. How do we make selections? We ask if the player strikes 3, I give him a bear. Otherwise, I may give him a water gun or candy. That is a selection. And the selection always have a condition. What is the condition here? What is the question here? I ask if the player strikes 3, in which the player may or may not strike 3. And you have to depend on that criteria to do action A or action B. That is how we call this as a selection. And it's making choice. In general, in any programming language, you have this. If there's such a condition is correct, that means the condition is telling you a truth, you do A. If the truth fail, you do B, okay? For example, if I have this 110 million billions dollars, what will I do? I will buy a car. I will eat a lot of buffets. I will go travel. I will quit NUS. Okay? What if not? Else, be good and study. Okay? So that is your decision. Of course, if you have that much money, you can still be good and study, okay? But just, you get what I mean, right? So, if you have that condition is right, you do the certain things, else you do the rest of things. That is how you make decisions. And doing certain things can be more than one. For example, this one also can be multiple instruction, okay? You can actually do a sequence of things when you make the decision correct or not correct. For example, you can even have nested so-called condition. If I have this $110 million and if I'm heartless, I buy all this. I buy this and eat things and so on. But what do I do if I'm not heartless? Then I actually, wow, so good, donate all the money to the charity. Okay, that charity will buy buy a condo themselves or something. Okay, but anyway, that is how you nest it. That means within one condition you can still do this nested if then, if then, if then. Okay, so that is how normally a lot of programming works with all these conditions. And one more thing is, you don't always need the else. Okay, that means if the condition is right, let's say if I have this $10 million, I do this. But now I don't have an else. What happened? That means that is quite important because it's quite hidden and a lot of people miss this meaning. That means if I don't have that money, what do? I do nothing. Exactly, somebody said. That means for this control structure, if this one is correct, I will do all these correct things. But if this control structure is nothing, then I actually will skip all the things and do nothing and jump to whatever next, which means the next statement after the if, okay? So you jump to the next so-called statements or whatever you afterwards, which means you skip everything, okay? So that is how this if without else is doing, okay? And yeah, this is the same thing. So go back to our quadratic equation solving. So what you just need to do is, if the delta is larger than or equal to 0, okay? I hope now you know what this means, right? Delta is larger than or equal to 0, then the condition is, then you do this. Normal, right? If the delta is larger than or equal to 0, then you can do the square root and you can compute the so-called the answer yourself. The contra is if it's not. If the condition is false, that means if this one is telling you a lie, okay? Delta is larger than 0, it's a lie. That means delta is less than 0. Then I will tell the user, sorry, your equation have no root. Okay? So that's how a condition works. And so you can see the structure of that is, if a condition, and you remember this colon, okay? A lot of people forgot the colon. And again, what do you see here? The indentation, okay? The indentation is the if, and you can see the else is here, and also a colon, and there's indentation. And there's a basic structure of this Python if then else. So you have an if, and then you have an indentation over here, and you can put the statement. So for example, if my money is larger than that, remember the colon and print good. Okay? And indentation statements. So you can do a few one as far as it's like the function, you have all the indentation, okay? If all under the indentation, then belong to that if condition. Then else, again, so if my account is equal to, I have $1,000, if my account is larger than 0, I print rich, else I print broke. So because it's larger than, that's why I print rich, okay? So if you change my account to, let's say, -1, then actually will print broke instead. Okay, so it's the else statement of Python. Yeah. And of course, you can put nested if, as I want to mention before. So A is equal to 4. If A is less than 10, I ask again, if A is less than 1, then I print here. And this could print nothing. Why? This statement is true, right? A is equal to 4 and A is less than 10. That's why I will reach this statement. But in this statement, is A less than 1? No, And that's why this one, I will actually go to the else, and there's no else. That's why I just do nothing. Okay, so there's all this if then else so-called exercise. Of course, in the else, you also can put if some more. Okay, the if area, this area, you can actually put another if, and this one you can also put another if. Okay, but one thing Python discover, if you do that, is very clumsy and very not good looking, right? So Python actually can merge these two together. That means Python like you to do this. If you do this, you can actually do something is called else if. Okay, if A is larger than 0, print yes. Else if A is equal to 0, print that. Else is what? So you can actually do this else if for you. Okay. For example, what is the usage? Let's say you are playing a game. The user give you a character, type in an action. Maybe A is equal to attack. B equal to what? B equal to what? B equal to let's only B. S equal to stop. W equal to walk. So you can actually ask if the user press A, then I do attack. Else if my user press S, do stop. Else if my user press what W, I do walk, and so on. Okay, so you can actually differentiate all the different structure branching with that, and as many as possible. Okay, you actually put a lot of sequence, and this one I actually do is something like this. This is a coin machine. Yeah, some people did it for fun, which is for like a.
I'm creating my website.
Not this one.
You think you already have
every
a
time this
website?
guy come up.
That's cool. You're welcome to skip.
Okay.
Or
okay, got it. So what this guy do is actually self-make a coin machine, and when he put the coin, we'll sort the coin for you. Okay. But at the end of the day, what he did is he actually make the paper. So you actually do this. So if the coin is that small, you actually slip in. Else if the coin is like that, you slip it here. Else is like that. So it's the else if, okay? So if the coin is very small, you go through the first hole. Else is your coin is a bit bigger, you go into the second hole. Else is if your coin is too big, very big, then you go to the last hole, and so on. So it's like a filtering process. You can actually else if and so on. And finally, you just glue all the things like that. Yeah. So you put this slide here, and you can sort the coin. Okay, so there's a else if things is like that. Okay, else if, and on the other way, you can actually think of this as the if and else statement. So you actually decide if it's true, you do this. It's like a coin machine, right? Otherwise, you slide here. Otherwise, if you go here and slide here and slide here. Okay, so you actually every of this branch, you decide whether you want to slide in or not slide in. Okay, so that is the coin machine. Yeah, so what I try to say is this one, if you want to implement this, is not all the condition. If you think about it, there's other condition. What if the two solutions are the same? What if other thing? Okay, so is your homework, try not homework as in you won't get any marks, right? But it's for your own fun. You try to figure out all the situation. Okay, what are the conditions? And to tell you the truth, this 99% of what programmers do. Figure out all the condition and lay it down in all the if to safeguard all the possible happening. You know that a lot of times you play games, right? I see bugs here, bug there. It's because programmer didn't do enough of this. If programmer do enough of this testing, whatever things will happen, then you actually have this all if and else statement to capture what you did, then won't have those bugs. Okay, so it's actually one very basic thing about if then else. Okay. So that is the if then else. We'll talk a bit more in the tutorial also, but it's in next week. This coming week, we will talk about the last week's topics about the evaluation and so on. The second control structure, remember we have the control structure of sequence and selection. The last one is called repetition, and in which you know it very much by your parents, right? Your mom always say, make the bed, make the bed, make the bed. Eat veggie, eat veggie, eat veggie. Go to toilet, flush your toilet, flush your toilet, flush your toilet. Okay, that's how you do it. Okay, but why is your mom repeating? Because if you flush your toilet, your mom won't repeat. So your mom is actually executing a loop. While when my son is still not flushing the toilet, I nag him flush the toilet. Or when my son still don't go home, I nag him go home, come home, come home, come home, and so on. Okay? So actually it's a repetition. But what I want to say is repetition always ends with a condition. Your mom still didn't come home because that is the condition he met. If you come home, she will stop the looping. And in computer science, it's the same thing, okay? If you achieve some condition, you will stop the loop, okay? So let's see. Remember the Pringle? What is the loop? The loop is, the simple one is, while I still have some price left, I continue the if then else, right? If there's still some price, I don't care, candies or bears or whatever, I keep playing the game, okay? And that's the loop. So loop is very simple. For example, always have a condition. While I'm hungry, I eat a bun. After I eat a bun, what happened? You go back to the loop first line to check if I'm hungry. Okay? If I'm still hungry, I eat another bun. If I keep this loop, I eat a bun, I'm still hungry, I eat a bun, I'm still hungry, I eat a bun, let's say I loop 10 times and I have eaten 10 buns. If I'm still hungry, I still going, okay? How to escape this? The only way to escape this is when you are not hungry, okay? So this hungry is actually a condition for you to escape the loop. That means the loop always have this kind of thing is you have a body. When the condition is true, you repeat that. You exit the repetition when you violate the condition. That means the condition is not true anymore, okay? Yeah, for example, while I have money in the bank, I take money, I eat, and so on, and then I go back to here. So that means if I still have money in my bank, I will still keep doing that. Until when do I exit the loop? When I have no money in the bank, okay? So that is the basic idea of loop in programming. And usually we call it iteration. There's a few names for that. We usually just simple because you know, right? The pronunciation of loop is a lot more than iteration, okay? And there's actually the more confusing that some people pronounce is iteration. Okay, I don't know where that comes from, but some people call it iteration, some people iteration, whatsoever, but I simply call loop, okay? But this is one of the things, when you encounter this word, you know that we are meaning the same thing, okay? So, they are usually concluded as 3 types of loops. The first type is, you know how many times you loop. Not like your mom. Your mom don't know how many times you lag, okay? So, that's how many times. The second one is like your mom. You don't know how many times you actually nag or loop until you got something. The third one is you actually know the maximum number of looping, but you may be lesser. Okay, let's see. The first type, I exactly know how many times I loop. Okay. You can use the function for. For in Python is for I in range something. That is a loop. Okay. That means you will actually give a variable I here, and the I will actually do something inside this one, and in this I has a value, and what is that value? The value will be the range n to m. So the first value of the I is n, okay? And the second one is n plus 1. The later one is n plus 2 and so on until n minus 1. Very good. I already didn't say it's also exclusive. Okay, it's like the string slicing is also exclusive. So let's say this. If I say I is in the range 0 to 5, and inside I just do a simple thing, print I, right? What will be the numbers? The first number is 0, 1, 2, 3, and then do I print 4? I do. Do I print 5? No. Okay, 5 is exclusive. So the final answer is 0, 1, 2, 3, 4. Okay, so that means I will have a value inside that such that when you execute anything inside, I is equal to that value. Okay, so it's exclusive for the numbers. So this one you actually can interpret as the first one is 0, 1, 2, 3, 4, and I is equal to 0, you print I. Of course, it's 0, right? I is equal to 1, you print I is equal to 2, I equal to 3, I equal to 4. That's it. Okay, you can interpret the loop like that. Of course, let's say if this one is more complicated, let's say this one is a field statement. Let's say a print I plus 1, then this one will become print I plus 1, right? And so on. You just replace this one with anything here, that with the I. Okay, you replace that. If it's more than one statement, that means you just repeat that chunk of code inside that with an I that is corresponding. Okay? And these are the same. So the first use you can know that is maybe you can use it for compute factorial. I assume everybody know factorial, okay? Factorial means you multiply, let's say n factorial means you multiply 1 to 2 to 3 until you multiply to n, right? In real life, how do you do that? I give you a paper and pencil. How do you do that? 1 multiply 2 equals to 2. 2 multiply 3 equals to 6. 6 multiply 4 equals to 24, right? You do that in real life. So what happened is from 1 multiply 2, you become 2. 2, the next number is 3, you become 6. Is it okay? Got it? And 6 multiply. So you can see this side of the table is the product so far. Okay? And you multiply 5 become 120 and multiply and so on. So computationally, you just multiply the number one by one and the loop goes like this. I start with my answer, which my product is 1. And the counter is each time into the loop, I do this, do this, do this, do this, and do this, okay? The counter will increase inside my loop from 1, 2, 3, 4, 5, okay? And what happened is my loop is, the counter is actually repeating this counter each time the counter plus 1, and my product is equal to product plus the counter, times the counter, okay? And after I finish this, my product will contain the final result and then I return it, okay? And this is the Python code. So my Python code, I actually want to write the function called factorial n. And what happened is, as just the English right now, the description before, product equal to 1. And counter, I can directly do this, right? Because the counter is from 2 to n plus 1. Why is it n plus 1? Why is it not n? Yes, because it's exclusive. You want to multiply 2, 3, 4 until n. You want to multiply n also. If you do this range 2 to n, then you multiply until only n minus 1. Okay, because you want to compute n factorial, you want to multiply n also. Okay, that's why you put n plus 1. But why do I put 2? Why don't I put 1? You can put 1, but just that you multiply 1 times 1, okay, which is okay, but it's just slightly slower or something. For the most efficiency, you start with 2, okay? And the product is equal to product times counter. This one I haven't taught the other class, but actually a lot of time you can shorten it. You can actually write a product is equal times equal counter is the same thing. Okay, it's a short form for that. Okay, if ever you do a equal to a plus 1, you can actually write a plus equal 1. Okay, later we'll talk more on the operators. Okay, so return product, that's it. When you finish the loop, the counter keep being multiplied into this product accumulatively. Okay, let's see how this works. At first, let's say I want to compute what is factorial 6. When you start, product is 1, counter is 2. Is it okay? You go here. Product is 1. When you first inside this loop, you start with 2, right? And that's why counter is 2. And product is equal to product times 2. That's why product will become 2. And the next time when the counter is 3, product become 2 already. Okay? And product equal to product plus counter, which is 2 times 3, product becomes 6. Next counter is 4, and you just multiply that like that. Okay? And when you finish, then you have the word 720. Okay? And when your counter is 7, actually it won't multiply again. You can see this one multiply, and so on, right? And this one does not multiply anymore into the numbers, because 7 is already out of range and it won't go into loop already. Okay? And that's why finally you compute a factorial product for that. This is a very typical loop. Actually, if you think about it, if you want to do summation, it's the same. Let's say I ask you, go home and try this one challenge. I want to just ask you how to sum up 1 to n. Of course, you can compute there's a definite equation, right? If you want to 1 plus 2 plus 3 plus 4, there's a definite equation. N minus 1 times n over 2, right? But let's say I want to use this method. I want to add 1, add 2, add 3, add 4, really add it together. Okay? Can you do that? This is the NR form. Okay? Yeah, so it's 1 plus 2 and so on. So the for loop have this so-called syntax. For there's a variable, so just now I use I, and this one is a sequence, okay? The sequence just now uses a range. The range is like 1, 2, 3, 4 is the range, okay? And then you execute the body inside. This is the one you actually repeat again and again and again, okay? And this is like the string slicing, the sequence. You can actually have this start, stop, step also. Okay, just now I give you the start and the stop, and you can also have a step. For example, let's say if I have, you can actually omit, okay? If you omit, you have a default value of 0 and 1, okay? So let's say if I just do range 10, Python will be clever enough that know that the 10 is the ending, and then it's from 0 to 10, okay? So this one will print you 0, 1, 2, 3, 4, 5, 6, 7, 9. Okay, it's as the same as for I in range 0 to 10. This one, you can start with the number not 1, okay, just like the the previous example, you can start with 3. So this one will print you 3, 4, 5, 6, 7, 8, 9, okay? And as what we said, we can do slicing, okay? That means this one is 3 to 9, but step 4. So the first number will be 3. The second number will be 7, is it? No, 3, 4, 5, 6, 7. Yeah. 3, 7, and the next number supposed to be 11, but it's already out of range. That's why this number will print out is only 3 and 7, because it's skipped. Okay? So it's like that. Okay? Let's do an example. Flipping coins. Okay? A coin we define is fair when I know the coin has this probability of half and half. You say so simple, but is it true in real life? You get a coin now, you flip it, is it really half and half? Do you know that? The truth is, it may not. This is an important verification process for a lot of casino. If the casino roll a dice, the dice, does it really have 1/6 chance of every number? You don't know. So the casino need to verify the dice. Actually, you don't know. The casino will really roll the dice 1,000 times before it roll out for you to play, and check if the dice really give you a fair chance. But you say nowadays all digital, right? You go and play the slot machine, it's actually all digital. But again, in the computer, is the random number generator, it can be still not fair. So we need to test all this to be fair, to make sure, let's say the slot machine, every of the combination will appear at the same chance. Okay? And we need to test it. So the most simple thing is, let's say if you're playing in the casino, it's a flipping coin games, okay? Heads you win, tails you lose. Then I need to make sure it's fair chance. How do I do it? Well, I can do a lot of cheap, profound math proof to prove my algorithm will produce something, right? But the other way, I don't care. My math is not good. I don't care about all those mathematical theory or whatsoever. I don't know number theory, whatever. What I can do is, like the dice, I actually work with it, really rolls out it for 1,000 times. That means I really generate 1,000 random number and I check how many of that is heads or tails. Okay? I use my program, I just repeatedly generate either head or tails, and I count how many of heads and the rest is tail, right? So, this is a simple flipping coin program, okay? So what you see is I actually include a package called random, and I just use one of the package here, okay? This one. But let's see what this function do. This function will print out something. We say I'm going to flip it 1,000 times. And this one is the number of heads. Before you flip, of course, there's no heads, right? There's 0 heads. Then I can actually flip it 1,000 times. You can see the loop actually will loop 1,000 times. And in this function here, rand in this random package, this rand in function will generate a random integer for you with the range of 0 to 1. But this is the pain in the head, okay? That this is inclusive. If you have been learning so far, right, the string slicing, whatever, is not inclusive, it's exclusive, right? This is inclusive. That means it will generate a random number of 0 to 1, including 1, okay? But anyway, at all, that means this function will randomly give you 0 or 1. If you increase the range, you can actually change this to generate any integer between 0 and 1,000, something like that, okay? If you want to simulate a dice, you can actually generate the number from 1 to 6, okay? Inclusive. But anyway, now we just flip coins, we just need 0 or 1. So if it's 1, I actually so-called increase the number of heads, okay? And then I print how many of them, and that's how I generate, okay? The program is here. It have been ignoring this guy for so long, and this one slip, and this one froze. Okay. Hey, I can't find it. I'll do it. Okay, but you believe me. This is after that. What happened is the number of heads will be close to 500. That means it will produce you 500 heads, something like that. Then it means your random number generator of this one is correct, okay? It won't exactly give you 500. If you give you exactly 500, it's also not random by definition, because you can guess the last one is 0 or 1, okay, if you flip 1,000 times. So this kind of thing is about randomness. But here, the main thing is show you I can repeat the thing a constant number of time and do a lot of experiment, okay? So the other way, other than for loop, is using the while loop, okay? While loop is exactly like the for loop, but just while a condition is true, then you run the body, okay? The condition is some expression, a equal bigger than 0 or something. So, for example, what does it do? Let's see. So in Python, I can do Python. Where's my Python? How come my idle is not working? Idle quit. Idle, yeah. Okay. So let's see. While true, print. You can see, right? What will we do? Okay, why it go forever? Because your condition is always true. It never affect that. Okay? And that's why it but first, what should we do now? Someone got a hammer and let's say just crash the machine or something like that. Okay, how? The thing is, if you ever do this, the famous thing is do Control C. There's interrupt. That's what Richard's quotation is about. Okay. Whenever you want to stop a program, Control C, you can actually stop it. Okay. And so this is the example. The other example is this one. What does it do? No, didn't switch. What does the right one do? Will the right one, the while on this side, do forever? Or what? It will not do anything. Why? Because the first time when you enter the loop, the condition is already wrong. Is it okay? So the second loop, so the problem of the loop is you need to figure out maybe your loop will go into infinite loop, or you actually didn't get in the loop. You need to get the condition right. And this is a usual joke for programmers. A programmer was walked out of the door and his wife said, "While you are out, buy some milk." And he never came back. Now, if you get it, you are a programmer. Why? Because while he's out to buy milk. So you will probably discover a guy in the street keep buying milk. Okay? But that's what computer do, okay? So that is usual computer jokes, okay? Yeah. So the while statement is very simple. You do a condition and you do it. And usually you should have some way to affect the condition, okay? That means you shouldn't have a condition that forever not change like the things keep going, okay? You shouldn't have that. You should have some way to control that, and reach some point it will change, okay? So the same indentation. So this is the same factorial I want to implement. The last version I use a for loop. This one I use a while loop, okay? So I actually do one more thing about the counter. Product and counter equal to 1. And while my counter is less than equal to n, that means within this loop body, my counter will be 1, 2, 3, 4, 5, because I'm actually incrementing my counter, but it will be less than n, less than or equal to n, okay? Then I do the same multiplication, and it's like, so 1, 1, 1, 2, and I multiply 2, 6, and so on. Then I just multiply it into the product, and my counter is keeping track until this one and this one will multiply that, and counter plus 1 becomes 7, and multiply that, but at this time 7 will be exceeding 6, and that's why it will stop, okay? So that is how you do it in a while loop. And let's see if you understand what I'm trying to say with this. When did my loop just start? If I call factorial 6, is this n equal to 6 or n equal to 7? I don't want to give you a definite answer, but when you do this looping things, it's like this. When you want the loop to stop, let's say this guy, I'm actually running this program. Will I check if I'm still on the cliff or I'm not? Or if I'm already out of edge or not? So what is the last boundary condition? For example, go back to this. Just now the loop, is it less than equal to n or less than n? I cannot give you a definite answer, okay? You need to think for different situation of the loop. But I just want to tell you this because a lot of time your bugs come from here. And I tell you a secret how to solve this. You try different one now. Just try. You try less than, oh, it works, okay. Oh, it doesn't work, try less than equal to. That's what I did also sometimes, okay. But of course, the best way is you figure out exactly why. But sometimes it's also this kind of thing to try out, okay. Try and error. Okay. Okay. So this one is the same flipping coin program, but I use a while loop. And the while loop is while the number of flip is less than 1,000. Okay, it's the same thing, but just a different way of counting. Okay. So nested while, nothing new. So this nested while actually give you this, and you can see that the easy way to think about that is this small while loop here print a small triangle, and then the large while loop just repeat it 5 times. That's why you have this like seesaw or Christmas tree shape. Okay. Yeah. Okay, so that's basically thing. So if you have this structure, you want to keep a number of times, and a is equal to a plus 1, usually you actually want to use a for loop. Okay? But why do we still want while loop is mainly because you actually want something like, you want to run the loop not definite a certain number of times. You don't know how many times you run, okay? For example, let's say we do another one like Pringles. This program, I will ask the user to input a number or type the by, okay? I did a typo here. This one should be or, okay? This one should be or, okay? Ask the user type a number or type the word by. So the number can type, the user can type a number, type any number of numbers until I say by. And then what happens is the program will sum all the number you type for you. How many times do you run this program? Nobody knows. It depends on the mood of the user. Okay? And that's why when I write this, I will do this. Sum so far, and I let the user to input the first time. And the answer of that, I will put it in this num. If the number is not equal to by, then I actually increase it and ask the user again. Okay? And I just keep the loop. And the condition to exit the loop is, so this is the way, the condition to exit the loop is this one. When the number is not equal to by. Okay? When the number is not equal to by, I keep adding the numbers. And keep asking the user for another numbers. Okay? And the thing is, I think for while loop, a lot of times is this you want to loop it if the number equal to by or not equal to by. Okay, this is usually the bug is, okay? When you have some loop, you either go into the loop or the loop go forever, you want to check this. Sometimes you think it differently. The key point for that is the loop body will keep repeating if the condition is true. Okay? We actually have a term for that, it's called invariant. That means inside the loop, that condition is invariant, which means it's true. When you break that condition, you exit the loop. Okay? So it's usually the case. So this one actually is true when it gets into the loop. Okay? Okay, the last type. We have indefinite time, and we have some so-called definite time, and we have something called maybe at most end time, okay? That's what you do usually if you check something, if it's all true or something like that. Let's talk about that, okay? For example, I give you a string. String can be anything, right? A, B, C, D, 1, 2, 3, 4, or even space or something. I want to ask you a question. If the string only contains alphabet. For example, this one, A, B, C, 1, 2, 3, is it only containing alphabet? No, okay? So I request a simple answer for you. I give you a string, you tell me this. If it's only containing all alphabet or not. So what do you do? How do you write a function to check it, okay? Return true or false. In real life, how do you do that? I write you a string, okay, on paper. How do you do that? You just look lah, okay? But of course, because it's so simple. But if you want to iterate, you see, is the first character an alphabet? Is the second one an alphabet? You keep asking, right? When will you tell a yes or no? When will you tell yes? You only tell yes when you carefully see each character until the end. And all of them are characters. Then you can say yes. But if any times inside that you see, oh, this one is a 1, is not an alphabet, do you need to check the rest? You already decide it's not all alphabet, right? So let's try another example, okay? Let's say, because we are marking a lot of script, what we do is we have different pile of the script. Some are marked, some are not marked, and we may mess up. The question is, if I give you a pile of script, how do you check if the pile of script is all marked? Okay, very simple. I just need the answer. The answer is either the pile of script is all marked, finished, or some of them is not marked. And in real life, what we'll do is, you need to come up with the answer yes or no. If you want to come up with the answer yes, the procedure is you check the script one by one. If the one is marked currently, what do? You don't do anything, you check the next one. Okay? Until you check all the scripts is all marked, then you can answer me, teacher, all the scripts are marked. Okay? How do you tell no? Same thing, you check the script one by one. If the script is marked, you do nothing, right? And you check the next one. Else, if the current is not marked, what do? You already can stop the process and tell the teacher, sorry, this part is not marked. Okay? One of them is not marked. So you already can tell them, just done say. Okay, so you don't have to check the whole part of the script. So if I combine these two together, I can actually have the following algorithms. Overall algorithm is you start checking the script one by one. If the script is marked, you move on. You do nothing. So there are two outcomes. When you meet a script this is not marked, you can already abort and say, no, some of them is not marked. Then you finish. But if you finish the whole part of the script and you just keep nothing, do next, and you actually finish the whole script, you can tell that, oh, the answer is yes, the whole part of the script is marked. Okay? And how do we translate to our problem? The problem is the same. You check every alphabet one by one. If one of the alphabet is alphabet, you do nothing. But if not alphabet, then you just return no. Okay? That means I check each of the alphabet, and if I find out one of them is not alphabet, I can actually abort and say that no, it's not alphabet. Okay? But when you can tell yes is you finished all the characters, and at the end you finish checking all the alphabets. And finally I can tell, oh good sir, I checked all the alphabets, they're all alphabets. And I can tell you yes, okay? And so on. And let's see, okay? Okay, where is it? Okay. Which line of the code is in the loop? Which means which line of this description is repeating again and again. Is this checking line, right? This one is whenever you get one alphabet, you need to do again. And that's why usually I will do the indentation, like that. Okay? And after this, that's what I usually do is after this, I can directly translate it into a Python code. So what I do is, this is the Python code. You can see it's almost a one-to-one correspondence, okay? You can see that first, you check the character one by one. You know that the length of the strings, and actually you can access the string I by different I, right? You see that the I will go from 0, 1, 2, 3, 4 until length -1. So this strings blanket I will access each of the character. And you ask, if not alphabet, then return false. You can see it's direct translation, okay? You just translate it. If current one is this one, right? Is alphabet. If it's not alphabet, that's why you put a not there, then return false. And after you finish the whole loop, if you finish the whole loop, that means you can see the indentation here, right? This indentation is here. That means all this here is in the loop. This is not in the loop. When you reach the return, that means you already finished all the looping, and all of them are alphabet, then you can actually return true. Okay, so that is the way of how to check everything. And Worst case is, if you want to check every alphabet is true, you have to look through all the alphabet. But if any one of them, you can actually skip. So you actually can check less than n times. But this kind of looping and this kind of escaping of loop is actually very common. Okay, I would say at least 3 or 4 assignments you will use some patterns like that. Okay, at least. Okay, so yeah. Okay, just lacking what is this one? This one I didn't tell you. Okay, this one is actually checking the alphabet using the lexicographical order. Okay, for each alphabet I just ask it, is it larger than A or less than Z? Okay. This one I will go through, skip it. You can actually see in the notes, figure out yourself because it's not the main point of the loop. Okay? We talk about checking all true. How do you check all false? Let's say I want to check if all the alphabets are not alphabet. Actually, it's quite simple, right? You use all the same logic, but just that you alternate the condition. Just now is when you check one is not alphabet, you shout. No, it's not alphabet. But this time I want to check if not all alphabet. Then you find out, oh, this one alphabet, then I shout, okay? So you just negate the condition. Okay, it's basically the same thing logically. How about check any true? That means I want to find in this string, I just want to any exist one of them. What does that mean? If I have all the characters, any one of them is a character, then it's true already. You can try to modify the algorithm yourself, but in the same time, any true is the reverse of all false. Logic. Okay? I ask, in this class, is there any of you is a guy? Sorry, I'm not challenging. Okay, I'm not challenging. Is your guy come and find me? It's not there. Okay? Is there any guy in my class? But someone can tell me the other answers. Someone can tell me if this class is all girls or not all girls. Is that sufficient? Because if the guy tell me this class is all girls, then my answer of is there any guys in this class is being answered, there will be no. If the guys tell me is this all girls, but the guys tell me no, this class is not all girls, then my question also answer, right? Because I know there exists 1 or 2 guys here. Okay? So if you check any of them true here, is exactly the not or the negation of all false. And so on. So that means basically this type of looping almost cover, I would say, 99% of all the loops you encounter in your life. Okay? So that's why I introduce all these type of loops. And in general, if you use for loops and while loops, for loops you know how many times you loop, and while loop you know, you depends on condition you stop. Okay. Lastly, I don't recommend this, but I want you to learn this. The loop you can break and continue. Okay. For example, you can see there's a break here. What does a break do? Whenever you reach a line of break, you exit the loop. That means you won't continue the loop anymore. Okay? For example, this, you see the j should be from 0 to 10, right? 0, 1, 2, 3, 4, 5, 6 to be 10. But when I equal to 3, I break. So what happened is 3 done. I won't continue. Okay? What is this? What is the difference between this and return? Return will totally break the whole function, will exit the whole function. But this break will just go to the exit the loop and continue inside the function. The other one is continue. Continue is kind of weird. It doesn't break the loop, but it go back. Okay? Continuous means instead of going to the next line, it doesn't go there. Continuous means go back to the loop. Okay? Actually, I have those arrows. Okay? So break means I totally jump out of the loop to the next instruction, and continue means I actually go back. Okay? So I go back and continue looping again. So you can see this loop is, if it's not equal, not divisible, you print that j, which is the odd numbers. But if it continues, we actually will skip this one and continue the loop. Okay? So continue means go back to the beginning of the loop and loop again. Okay? So start the loop again. But I personally will not recommend you to do this. From my programming experience, I don't need to use it at all. Because when you use this, maybe there's some logical error or the thinking not so nice in your overall algorithm, right? But you may still have 1% chance of using this, okay? This one, anyone know this Monty Hall problem? Probability. Oh, no. Oh, you know, good. You want to come and tell me? No. This one is very simple. Think about it. Now I'm the MC. Behind these 3 doors, there's a goat, there's a car, and an empty door. The game is very simple. You name ABC, open the door, and you get what you get. So you may get a goat, you may get a car, or you get nothing, okay? The game begins. You come, you choose A. But what I'll do is, now I don't open that. I open the other empty door for you. Or open the ghost door for you, which is not a car door. Now you still have your choosing door and another unopened or closed door, right? The question is, will you switch? You seems like, hey, that doesn't give you anything, okay? Switch, no switch, doesn't matter. But if you study probability or statistic, if you switch, you double your chance of winning a car. Okay? And I can continue to start all these probability and give you, what is that, STA 101, whatever, teach you all this. But I don't want to do that. As I say, I don't want to be good in my math. What happened is I can actually run a program. Oh, sorry. Run a program here. Which means I just do statistically like a flipping coin. This program here. Okay, I just run my Monty. Wow, okay. Because it's the screen thing, Monty Hall. Okay, what I do is this Monty Hall program, I will actually ask, I will switch or not switch. Then I run the program randomly 10,000 times. Switch means the player will switch to the other one. Not switch means it doesn't. And I count the experiment with all these random numbers and I run it. What happened is, run the experiment 100,000 times, the player won't change his mind. The chances of winning a car is 33%. Okay? But if run the experiment 100,000 times and the player will switch according to that, the winning chance is 66%. Okay? I don't know what is the magic behind this math, but this experiment shows that it's true. Okay? This is another way showing that. So next time if you go to probability class, you say, I don't care, can I give you a program to pass my exam? Okay? So, okay? So before we go, let's see how do we write a love program in Python, okay? This is how you write a love letter to your girlfriend or boyfriend in Python. Can you interpret it? How is this? That is, it means everything I say will be true to you, and you are my everything. And then, my mind only have you. And I don't have an if statement because my love is unconditional. And it's a forever eternal loop, I love you. And you can see my function don't have any return because I don't expect any. Isn't that romantic? Okay, so you can try, okay, go home, okay? Yeah. Okay, so thank you. Okay. So at last before we end, remember there's a colon, there's indentation, okay? It's the while block, whatever, define, whatever, it's like that. And there's indentation, there's indentation. Remember that? And the inclusive, exclusive things is a bit pain, okay? So far only the random in is inclusive. You can treat 99% of them is exclusive, okay? So far that's it all. Before we end some administrative stuff, the tutorial will start this Wednesday already. So please go and learn. And also the good thing is have a look at the worksheet first. That is already in cosmology. Yeah, so if you still have problem installing Python, please try to fix it. If really have problem, go to the tutorial and ask the tutor after the tutorial, okay? So the tutor actually is there to help you, okay? Thank you.